Today we will focus on converting from standard form to turning point form. I'll have timestamps in the video, so feel free to skip to wherever necessary. So there are three main forms that we need to be aware of. Only two will be important today, but we've got standard form, and you've got turning point form. This is also known as a vertex form or vertex. Then you've got intercept form. And the way that we convert from standard to turning point, from there to there, is by completing the square. Completing the square. Now I'm going to remind us all how we actually do complete the square. So complete the square steps. So I'm going to assume that we're only dealing with the case where a is equal to 1. So this is going to leave us with x squared plus bx plus c. For those who already understand this and want to know how that works, leave a comment and I'm happy to make a video on that. Alright, so the first thing we need to do is identify b. So identify b. Then we have to do b on 2 all squared. Figure out what that number is. We're going to add that number, and then we have to minus it so that there's no change. If we add something and then we minus that same thing, it's the same as like adding 0, which doesn't change our equation or anything. So we've now got y is equal to x squared plus bx plus c plus whatever b on 2 all squared is. Then we have to minus b on 2 all squared. Now I'm going to rearrange. You don't need to do this, but this just might make it clearer. So we've got x squared plus bx plus now b on 2 all squared plus c minus b on 2 all squared. Now we can write we can write these first three terms here as a perfect square. So x plus b on 2 all squared. If you don't believe me, go ahead and try expand it yourselves. And then we've got plus c plus b on 2 all squared. Because we've got no like terms, there's no other way we can sort of factorize this or do anything different or simplify. We've now got it in our turning point form with our h there and our k there. Now, let's go through a short example where y is equal to x squared plus 6x plus 5. So we're trying to complete the square if we want to go from standard form, so standard to turning point. We are completing the square. Alright, so let's first identify what b is. So b here is equal to 6. Now 6 divided by 2 all squared is 3 squared, which is 9. So now I'm going to add that. So plus 6x plus 5 plus 9 minus 9. Now I'm going to rearrange. Again, you don't have to do this once you get better at it, but just to make it visually easier for now. Now I know that x plus 6x plus 9 is going to simplify to x plus 3 all squared, and then 5 minus 9 is equal to minus 4. So now we've got it in turning point form. So it's in the form of a brackets x minus h all squared plus k, where h is equal to minus 3 here, k equals minus 4, and a is equal to 1. So our turning point for this graph, or the equation, is -3, -4. The motivation behind going from standard form to turning point form is to give us a form that tells us where the turning point actually is. So we can find the x-intercepts by setting y equal to 0 and solving using quadratic formula, whatever method you prefer. Then we can find our y-intercept by setting x equal to 0. And then if we have it in our turning point form, we can easily read off where the turning point actually is of our graph. and this allows us to easily graph our quadratic.